Good evening, everybody. I'm Suhana Singh, and today is day 3 of learning machine learning in the simplest way possible. So, day 3 is going to be about the most popular machine learning algorithms with everyday examples. Introduction first. Today, we're diving into the heart of machine learning, that is, algorithms. Now, think of algorithms as recipes or tools that teach computers how to learn from data. Each algorithm solves a different kind of problem, and knowing when to use which one is the key. So by the end of today's session, you'll know what the most popular machine learning algorithms are. You'll be knowing how they work in simple terms, and where you've seen them in everyday life. Starting off with the first algorithm, that is linear regression. Linear regression is drawing a line to predict. It is used to predict a number like a prize or score based on the input features. It finds the best straight line through data points. Now, how does it work? So imagine you want to predict the price of a house based on its size. So how do we do it? We collect data, that is the size and the price of the house, put size on the x-axis and price on the y-axis. You get scattered dots on a graph. Linear regression finds a straight line that goes to the middle of those dots as best as possible. It doesn't touch every dot, but it's the closest overall. This line represents the general trend. That is, bigger the house, higher the price. So the everyday example, linear regression is used in real estate websites. So real estate websites use it to estimate house prices based on features like size, location, and age of the house. Next, we have logistic regression. Logistic regression is used for binary classification, that is, answering yes or no questions, like, is this email spam? How does it work? Instead of predicting a number like in linear regression, it estimates probabilities. If the probability is above 50%, the model says yes, otherwise, no. So it uses spam filters. Email spam filters decide if a message is spam or not based on things like subject lines and keywords. Next, we have decision trees. So decision trees it's a tree-like model that makes decisions by asking a series of yes or no questions. How does it work? Each question splits the data. Eventually, you land on a final answer based on your path through the data, through the tree. Everyday example, banks use decision trees to approve or reject loan applications based on income, job status, and the credit card history. Now we have random forest. What is it? Random forest, it is an ensemble. So ensemble means a group working together as a team to make better decisions. So a random forest is an ensemble of decision trees working together for better accuracy. Now, how does it work? So in a random forest, each tree in the forest looks at the input data and gives its own prediction. For example, if the task is to decide whether a transaction is fraud or not fraud, one tree might say it's fraud while the other one might say it's not fraud. Once all the trees are voted, the forest uses the majority decision. That's random forest. Example, credit card fraud detection systems use random forests to flag suspicious transactions. Now we have k-nearest neighbors, also known as KNN. What is it? It's a simple method that classifies new data based on the closest existing examples. How does it work? Now, KNN looks at the K. So K is nothing but a number you choose. It looks at K closest data points to a new item. It checks which group most of those neighbors belong to, and then the new item is assigned to that group. Where is it used? Streaming platforms recommend shows based on what similar users are using or watching. Next, we have K-means clustering. It is an unsupervised algorithm. Here, a computer goes through similar things together on its own, without being told what the groups are. So how does it work? It picks a center for each group, then checks which center each data point is the closest to. Each point is then grouped with the nearest center. It's like joining the closest team. Everyday example. E-commerce sites use K-means to group customers with similar shopping habits for targeted marketing. Next is support vector machine. SVM, it separates data into two groups using the widest possible margin. How? It draws a boundary line or plane that maximally separates the two groups. Everyday example. Face detection in camera apps uses SVM to distinguish between the face and the background pixels. Now we have neural networks and deep learning. So as you see by the name neural networks, it's inspired by the brain. Neural networks consist of layers of connected nodes, which is like the neurons, that learn to recognize complex patterns. How does it work? Data flows through multiple layers. Each layer extracts deeper insights. And deep learning means many layers working together. Everyday example. Voice assistants like Siri or Google Assistant use deep learning to understand what you say and generate a response. The last one, ensemble methods. Ensemble methods, it is one method that combines multiple algorithms to make more accurate predictions. How does it work? It blends the strengths of different models, like taking the average or majority vote from different experts. Everyday example, you see these in weather apps. Weather apps use ensemble methods to combine predictions from several models for a more reliable forecast. I've made a summary table consisting algorithm, what they're good for, and their everyday example. So you can see linear regression is good for predicting numbers used in house prices. Logistic regression, yes or no questions, spam filters. Decision trees, good for asking questions, used in loan approval. Random forest, good for decision making, used in fraud detection. KNN, classification and recommendation. Everyday example, movie recommendations. K-means, finding groups. Example, customer segmentation. SVM, used for drawing boundaries. Example, face detection. Neural networks, used for complex learnings. Example, voice assistants. And ensemble methods, good for teamwork. Example, weather forecasting. Now conclusion. Every algorithm we covered today is like a different tool in machine learning toolbox. Some are simple while some are complex, but all solve specific problems effectively. So, today we learned the most widely used machine learning algorithms, how they work in simple terms, and we also saw some real-life examples where they're used every day. Thank you.